so two things I wanted to do tonight. Of course, I want to cover the Module 6. I want to cover Module 6, but I also want to open up a dialogue for any questions you might have because your projects are coming due soon. And I know everybody for week 5 turned in their story maps and their pseudocode or flowcharts. But programming is going to start happening very soon. So think about questions you have and let me know what they are tonight if you have some. So I am going to share my screen and we will get started on Module 6. So tonight we are talking about lists and dictionaries, basically collections. So what is a collection? A collection is a way to store like data, okay? It's a way to store a grouping of information into a variable. And there are structures associated with lists and dictionaries, and there is of course syntax, and a lot of the things that we have done up till this point, looping especially, is going to come into play when we talk about processing lists and dictionaries. You will find out that the for loop is your friend when it comes to lists and dictionaries. So yeah, this is, well, let me say this. A dictionary, if you've ever heard of a database, you know, I'm sure everyone has. There are SQL databases and there are no SQL databases. And no SQL databases, like MongoDB, which is a big one, are basically are based on the principle of a dictionary. And a lot of the processing I do in my work deals with collections of information, because almost nothing that we do as programmers, or that I do as programmers, for the type of programming I do, has to do with just a single variable. There are single variables that we use, but there are collections of variables, collections of data. So the first type of collection we're going to talk about is a list. And a list is, hold on for just one moment, please. Okay. A list is a collection of data that, and it can be anything. You can have strings, you can have integers, you can have floats, you can have other collections, you can have dictionaries in a list in a dictionary. But a list basically is just a straight collection. You have one piece of information followed by the next piece of information followed by the next piece of information. And you'll see why this is different when we come to dictionaries. A list has a syntax and you use square brackets. That's what tells Python that you are using a list, is square brackets. So I'm going to do just a real simple list. Let's see. And we'll show you some of the syntax. By the way, does anyone else have sound? So you guys, can you guys not hear me? Okay. Can anybody hear me that's out there? Okay. So, I'm not sure what's going on your end, Noah. So yeah, I'm not sure what's going on your end. Okay. So a list is a structure. And by the way, you're going to need to use lists and dictionaries in your final project. Good job, Noah. Good for fixing it. So I'm going to start a list called my list. And I'm just going to do that. And that's a valid Python statement. So what did I just do? Okay. I created a variable called myList. I know it's a variable because it's on the left-hand side of a single equal sign. On the right-hand side, I put an opening square bracket and a closing square bracket. This tells Python this is a list. To expect, well, that it is a list. So that's what it tells Python. Now, there's nothing in the list. This list is empty. If I said print my list and I ran this, oops, I have to configure my interpreter as always. Okay, so if I ran this, I'm going to get a square bracket because that's all I gave it. Now, that square bracket is not a string. It is simply a way for Python to tell you that what it's printing out is a list. So there are a couple of ways I can put data into my list. I can simply put data into my list. I can say Lisa. I can say I can say IT 140. I can say 5. Say 22.3. I can say true. All of those are valid in the same list. Now, if I run this again, and notice the only thing I did was enter information in between those square brackets, I have all that information in between the square brackets. So I have populated my list. I have given my list information, and I have given it a place to start. So when you're doing your project and you're and you have a list of rooms, let's say, that's potentially how you would set up a list of rooms if that was the way you were going to do your project. Now, there are other ways to get information into and out of a list. But there are also ways, what I want to talk to you for just a second is how to get to the data in the list. Because this has information in it, but I don't necessarily always want this. Maybe I just want to get to 22.3. So how do I get to data in a list? Well, I get to data in a list by using the index value of the data in the list. So I'm going to not print my list right now, but I'm going to do this. I'm going to print my list of, and that's how you read this, 0. And let me do this. I'm going to say okay. And I can type tonight, maybe a little bit. Okay. So I'm going to run this again, and I have my list of 0 is Lisa. And that's because, I know we talked about this a while ago, but like I think it was module 2. It might have been module 1. I want to get at the first piece of information in my list. And the way I do that for a list is using an index value. Now, for lists in Python, indexes always start at 0, and they go to 1 minus the length of the list. So in the case of my list, we see that it has 1, 2, 3, 4, 5 elements. And that's what those are called. They're called elements in the list. But if I start at 0 and I went to 5, I would actually be trying to get to the 6th element in the list, and I'd get an error. So let's just do this real quick. And then I'm going to change it to a for loop. So I'm just going to really quick do this. 1, 2, 3, 4. And I'm going to say 1, 2, 3, and 4. So if I do this and I print this out, you will see that my list of 0 has Lisa. Lisa is 0. IT 140 is 1. 5 is 2. That's the element. It's at the 3rd position, but its index value is 2. 22.3 is, you can get to it with index value of 3. And true, you can get to it with index value of 4. So let's see what happens if I do an index value of 5. Anybody know what's going to happen? I'm going to get something called an list index out of range. It's a very common error. It happens all the time. And it's basically when you walk off the end of a list. 4 is the last valid index. 0, 1, 2, 3, and 4. So the last one you can get to is 4, is the 4th index. And the minute I go to 5, which means it's looking for a 6th element in the list, Python says, sorry, can't do it. Going to stop here, and I'm going to give you an error. And that's what an index out of range means. Now, this is all fine and good. I did all these wonderful little print statements. And I'm just going to comment them out right now. And I'm going to show you an easier way to do the same thing. With just a couple of tools that we've already talked about. Because this is not the most efficient way to process a list. It certainly isn't. What you want to use is you want to use a for loop. For loops were made for lists in Python. They are made to go together. So if I want to do the same thing I just did, but I want to write fewer lines of code, and I want to be able to make it useful if my list changes, I'm going to do a for loop. And there's a couple of different kinds. I can do a for, an elem is just a variable. I'm just giving it a name. In my list, print elem. And I can do this, and it just does that. 2 lines of code, and I have all that information. Now, that's one way I can do it. You'll notice I don't have an index value. All I'm doing is I'm going through each element in the list, and I am printing it out. Now, that's really handy. That's really handy if I don't know how many things are in this list. Or if today's Thursday, and on Thursday there are 4 things in the list, and on Friday there's going to be 12. But I can use the exact same 2 lines of code no matter what. So I can add some, whoops, my apologies, add some more code. Now, the nice thing is, lines 3 and 4 are going to do exactly what lines 3 and 4 are going to do. I just added another piece of information to the list, and lo and behold, it comes out here. I didn't have to do anything to lines 3 and 4. This is data-driven code, and that is the backbone of all programming, in my view. And oh, by the way, my apologies, something I should have covered. The syntax for a list is open square bracket, close square bracket. What is inside those brackets, each element, has to be separated by a comma. So this is basically a comma-separated list, or a comma-separated structure, and that's what makes a list. So it doesn't matter what this is. It could be an integer, it could be a string, it could be a Boolean, it could be another list, but they have to be comma-separated. Otherwise, there'll be an error. So if I just removed that comma and I tried to run this, I'm going to get an invalid syntax error. Now, this is one of the few times that Python is going to tell you exactly what's wrong and where it's wrong. It says there's invalid syntax and it points to true. And that's because there's no comma between 22.3 and true. I put a comma there and I'm back in business. So, how else can I access stuff in a list? Well, again, I'm going to use a for loop, and I'm going to use for counter in range, R-A-N-G-E, yeah, range len of my list. And then I'm going to use a very similar print statement to what I have down here. I'm just going to change it a little bit. I'm going to say print my list of is, and I'm going to say format, counter, and my list of counter. Now this is useful when you need to know what element you're at. Let's say if you're splitting things up by what's an even row and an odd row, let's say. So here I have a problem. Okay, so because that's why. Okay, I had one too many curly braces there. So here I have two different, I have this one, which I have already used, it's right here. And then here I now have a little bit different printout. Because I am using counter, and counter is just a variable, that's all it is. And in this case, I am, or actually let me do this, let me make it index. So it's a little bit easier to understand. So for index in length of my list, we talked about this several modules ago, but len is a function that you can use. Len tells you the length of something. And in this case, the length of my list is going to be 6. Now, the range function already knows that indexes start at 0. And there are, and we'll see in a bit, there are ways that you can change that so that you start at a different place or you end at a different place or you skip things based on what particular, maybe you advance 2 instead of advance 1. So this is very helpful if you need to determine information based on the index of something. So those are two different ways to access elements in a list. And there are now also ways that you can add information or remove information from a list. So if I wanted to add, here, let me do this. I'm just making it a little easier. Yep. I'm just going to make the printout a little easier to read. That's all I was doing there. So now I want to, well, let me go back to zyBooks, and then we'll go and we'll come back to this. So accessing list elements, that's just what we talked about. Everything starts at 0. It goes to 1 minus the length of the list, and you can easily walk off a list. A list is mutable. This is what I wanted to get to. When we first talked about strings, I said that strings are immutable. They cannot be modified. You can create a new string with a modification to it, but you cannot actually modify a string. Lists, on the other hand, are what they call mutable. You can modify the list. You can modify it all different ways that you want. And you can create it, and the acronym is called Create, Read, Update, Delete, or CRUD. And that really is an acronym, but that's what you can do to a list. You can create it, you can read from it, you can update it, and you can delete it. And the syntax for a list is there's some interesting syntax that Python uses. You can, what we've already seen is creating a list. You can also use this list iter to create a list. And what that will do is that will populate a list based on the data that you give it. So in this case, they're giving it the string 1, 2, 3, and it's going to take that string and break it apart and make it a list. I don't use that much, but it's very valid, and I'm sure there are some people that do. We've talked about the index. This is a little bit more than just an index. So the my list, where you have a start, colon, end. So you're getting a new list containing some other list elements. So you can get, let's say that as the example here is 1 and 3. So it's going to get the first, it's going to get element at index of 1, and is it 1 minus 3? No, it's just 3, so this one's wrong. You can add two lists together. We'll see an example of the start and end that's better. You can assign a value in the list to another value. You can assign a position in the list to just a value. There's also an append, which will allow you to add information to the end of a list. There is delete, which will delete an element from the list. So you're actually going to shorten the list. Append will lengthen the list. Delete will shorten the list. Those are the only way to actually change the length of a list. So that's important to remember, because I think that one of the challenges or one of the labs you're going to have to use that. Let's keep going. Okay. So this is basically modify short names by deleting the first element on the list and changing the last element to Joe. So this is basically going to do a delete, a del, for my list of 0, and then we're going to use this to change it to Joe. And I'll spend the time on challenges once we get to a little bit tougher challenge tonight, because I think we've kind of done some of this when we talked about lists previously. Common list methods. Append, we just talked about. You can add information to the end of the list ad infinitum. Extend will add a series of items to a list. So you can add another list to a list. You can also just add them together. Insert will insert a value before a position. You can also remove things. You can pop from the list. Pop usually just removes it from the top. And these are handy if you're ever doing stacks, like a message FIFO or something like that. And you're not going to be expected to remember any of these. Sort is important. You may want to keep sort in mind. And it sorts the items in the list to some predefined order. So if it's an integer, it's going to sort it from lowest to highest. I think if it's a string, it'll do it alphabetically, but I have to go look. Reverse is the reverse sort order. And then you have returning an index given a value. So it basically does a search based on the value, and it counts the number of times something is in a list, because a list is not unique. You can have the same information over and over and over again in a list, which is something to remember with your game when you are collecting, when your player is collecting items in their rooms. You don't want to have the same item in the list 10 times. You only want to add it once. So you have to remember that lists can have the same value multiple times. There's nothing to stop it. Iterating over a list, we talked about that. We talked about two of the most common ways to iterate over a list. Using the syntax for element in the list or for index in range. So those are the two most common ones. And what are these? These are just some more, they're very handy. Python has a lot of very handy functions. You can use min and max. So let's say you have a list in a lab and you're looking for the minimum or the maximum element in that list. Remember that there's a min and a max, or max and min. There's also a sum if you need that. So when you're starting to deal with things like collections, my suggestion is to go to Google and look up Python lists. And there are some very good documentation. Python has some excellent. W3 Schools has very good documentation that will talk about lists, orders, changeable, all that stuff. They have great examples. So it's w3schools.com, Python lists. But you can also just do a search, and that will be one of the first things that come up. And then let's do that again. The other place I suggest people to start with is the Python documentation itself. Python documentation is great. The nice thing about the Python documentation is you can tell it which version of Python you're using. And so let's say you were using 3.9.4. It's always, by the way, going to default to the latest version. And it will tell you every single built-in function there is to do to a list, and it will give you examples. So if you're getting stuck, or if you're not sure and you're saying, hey, wait a minute, do I need to go out and write a function to figure out what the minimum thing in the list is? Or can I simply use something that Python always has? Always go look to see if Python has it first, because they did it and you don't need to redo it. So let's see. I'm going to wait till we do something like a split and a multi-dimensional list. List games. The following activities help you become comfortable with iterating through a list. So this is just about iterating through a list. And iterating through a list is very simple to just iterating through anything. If you have gotten comfortable with for loops, then you're going to be comfortable iterating through a list. So now the next thing is what they call multi-dimensional lists. And a multi-dimensional list is just a list that contains other lists. And you can do this ad infinitum. You can have a list that contains a list that contains a list. We're only going to do two-dimensional lists in this class. One of the things, let me do this. Let me start with a new file. If you are if you have ever done something like an Excel spreadsheet that has rows and columns, you will be basically a multidimensional list is rows and columns. So I'm just going to do some examples here. And I'm going to just, my multi-list, I'm just going to say my multi is, now I have my syntax here again, and I'm going to say, I'm going to just add another list inside of it, and I'm going to say 1, 2, 3, and then I'm going to have a comma, and I'm going to say 4, 5, 6, and I'm going to have another comma, and I'm going to say 7, 8, and 9. And I'm just doing integers because they're easy. Now, another way to set this up to make it a little more readable is this, okay? So what you'll see here is you will see a list, my multi, that contains 3 other lists. And that's what these are. 1, 2, and 3 is a list, 4, 5, and 6 is a list. And I can make it a little easier to read. Just add spaces. It doesn't matter. So how do I iterate through this list? Well, this is how I iterate through the list. You're always going to start with the row and then go to the column. So I'm going to do 2 different ways. I'm going to do it based with just going through my multi-list with the for loop, and then I'm going to do it based on indexes. I'm going to say for row in my multi, and then I'm going to say for cell in row, and I'm going to print cell. That's all I'm going to do. 3 lines of code, 2 of which are loop controls, to get to that information. So if I run this, you'll see 1, 2, 3, 4, 5, 6, 7, 8, 9. So what happened? Well, let's go and take a look at what happened. I'm going to put a breakpoint here, and I'm going to debug this, because I find that it's easiest to understand what's happening in a loop if you can iterate through it. So I am on line 7 in the debugger, and I have, here's my multi. My multi-list has 3 lists in it, and I'm on row 1, 2, 3. So if I go down here and I look, row is this first list. This is a row. And then I get to cell by going through the row. So row is 1, 2, 3, and my cell is going to be 1 because I'm at the first element. So if I step over this, it's going to print out 1. I'm still on row 1, 2, 3 when I go to line 6. Now I'm at cell 2. I am now still on row 1, 2, 3 at cell I'm 3. Now, what's happening? It's saying, well, cell is 3. And let's see what happens when I try and step over this. Well, it's going to go back up to the top of the very first loop because these are nested loops. And when I now move down into the first loop, it's going to change the row to 4, 5, and 6 because it finished with everything in the first row, in the row with 1, 2, and 3. And now I'm going to go and I'm going to do 4, and I'm going to do 5, and I'm going to do 6. And then at this point, because I'm done with 4, 5, and 6, I'm back up to the top of the first one, and I'm now on 7, 8, and 9, and I'm going to go through 7, 8, and 9, and then I go up to the top, and there are no more lists, so I'm done. And I've printed out all of those numbers from a multi-dimensional list. The other way, there's other ways to access this. One of those ways is here, by doing just this direct print statement. Print, well actually let's do it like this. We're going to do this with a for loop. I'm going to say for row counter in in range len of my multi for cell counter. Actually, I'm going to use index. In range len, wait a minute. Yeah. For cell index in range len my multi of row index. And I'm going to print, if I can type tonight, I'm going to print my multi of is dot format row index cell index my multi of row index of cell index. Okay, so here's another way to do this. So instead of doing this, which is really quick and really handy, we're doing something almost as quick and almost as handy. In this case, I care about the index number. So, and you will in some cases care about what index value the information in the list is. So this time I'm going to use the index in range, and so for the outer for loop, I'm going to have a variable called row index, and I'm going to say it's in the range of the length of my multi. So it will start at 0, and it will go to the end. It will go to the last element. And then for cell index, and by the way, we haven't started dictionaries yet, so I hope it's okay with everyone. We're going to go over some tonight. So now cell index is for, it's going to go and look at the individual elements inside the row. So here I'm going to say that the length is my multi of row index, so I know what row I'm on. So if I run this, I got an error. Placement index 2 out of range. Row index, cell index. That would do it right there. Parenthesis in the wrong place. Okay, so here is the new stuff. My multi of 0, 0 is 1, of 0, 1 is 2, of 0, 2 is 3. So this, what that's telling us is that is row 0. And so at row 0, the element for the cell 0 is 1. The value of the row of cell 0 is 1. And now you're saying, well, why do I need to run this through something like that? Well, what if this changed to A? So I don't have 3 here. I still need something variable. And I run it again, and the same code. What did I do? Four, 5, 6. A, right there. It was there. I should have made it something different, like AAA, so I could have seen it easier. So this code works as long as for anything you have in this multidimensional list. And that's going to be important because one of the labs you're going to do has multidimensional lists tonight. I think they use a tic-tac-toe thing here. So this is their example. List slicing. Okay, list slicing is extremely handy because you can take a list and cut it up, and that's this particular notation here. So you can take information out of a list, a range of information out of a list, and make a new list out of it. It's quick, it's very easy, and yeah, it's quick and easy. And what I use more, and what we will use more in this class, is when you split. So loops modifying lists. So you can actually change information in a list while you're going through the list. And you can just do that by setting the index value. So for this, let's just say I'm going to print this out, and I'm going to say if row index is 4, 0, 1, 2 is 3, sorry, is 2, and column index is 3, cell index is 3, I want to modify that, and I want to say my multi of row index and cell index is now going to be 42. And here I'm just going to move this. I'm just going to print that out. So if I run this again, and let me do this, comment this guy out, just to make it more readable. If I run this again, you'll see 1 and 3. Hold on. That's why. 0 and 1. If I run this again, this becomes 42 because I simply changed the value by just setting it, because my multi is a multi-dimensional list, and it's just a variable that has a specific structure. So at a specific row and at a specific cell, I want to change the value. And in this case, I want to change it from AAA to 42. Now, I also could have done it like this. So let me do this and this. I could simply say if row index of cell index is AAA. I want to change my multi. I'm just going to copy that. Is 42. So that's another way I could have done this. So if I run it, I get the same outcome, but instead of looking for an actual row index and cell index, I am looking for a value within the list, and I'm modifying that value. Okay, so let's keep going. This is kind of, list comprehensions is a short, it helps you kind of do a shorthand for list. Everything that we've done can be done with a list comprehension. A list comprehension can always be done with with the longer way that I've been showing you. So this is kind of a shorthand. And for some people, this is extremely easy to read. From an underlying processing standpoint with Python, it is it's the same. Python will optimize when you're going through the interpreter. So I'm not going to spend a lot of time on it. Sorting lists, you have a sort function. You have a sort and you have a reverse. We talked about those a little bit. Command line arguments are really quite interesting, and they are considered lists in Python. You won't really be using them that much because we're using input. We're not using command line. This is some engineering examples. Let's see. Varied amount of input data. Statistics are often calculated by varying amounts of input data. Write a program that takes any number of integers as input and outputs the average and the max. So we know what to do here. We know how to take in some number of integers. So in this case, I would use a while loop. So let me just give you an example that's not exactly this, but is similar. So this is going to be, what is it, lab 6.12. Go back here, lab 6.12. So in this case, we're going to be using two things. We're going to be creating a list. We're going to be using a while loop. And this is important because this is something similar you're going to end up doing for your program, for your game. We're going to use a while loop to take in some number of information, and then we're going to find the average. So I'm not going to show you exactly how to find the average, but I do want to go through the mechanics because it's important for not just this lab, but it's important for your program. So in this case, I'm going to use my list again, and I'm just going to set it to an empty list. Then what I'm going to do is I'm going to say while, I'm actually going to have a helper variable, and I'm going to say stop equal go. So I'm going to say while stop is not equal to Q. I'm going to say L equals so now here's where the append comes in. I'm going to say my list dot append, and it's going to be val. And I'm just going to right now, when this is done, I'm going to print my list, and then down here, I'm going to say calculate the average. So you're going to have to calculate the average. So this is the control structure, a very similar control structure that you're going to have to use in your game. So that's kind of why I'm going through it right now. So let's just change this. And we're going to run it and see what happens. So please enter an integer. I'm going to enter 1, I'm going to enter 2, I'm going to enter 3, and I'm going to enter Q. And that's why. So I didn't do that right. I'm going to say, please enter an integer or Q. So here, I'm going to be a little more savvy about it, and I'm going to say if val, don't write Java, Lisa, val is Q, I'm going to break. Otherwise, I'm going to add val to my list. Well, now let me try it again and see if it worked. So I'm going to enter 1, 2, 3, and Q. And there I have it. Now I didn't finish it because I did not calculate the average. You still got to calculate the average. But I wanted to do this lab because this is in essence the beginning of the control structure for your game. And I know we're running late, so I'm going to, this is filter and sort. So it's going to be very similar to the first one. You're going to get a list of integers from input. You're going to output non-negative integers in ascending order. So you're going to have an if statement. You're going to sort in ascending, so you need to look at the difference between the sort function and the reverse function. And so this is similar to what we did. Dictionaries. Dictionaries are a completely different form of collection. Dictionaries don't have they don't have indexes. They are an associative list. They're an associative array. And what do I mean by they're an associative array? Let's do an example. So here, I'm just going to create a simple dictionary. And dictionaries have a bit of a different syntax. So instead of the square brackets, they have curly brackets. So I'm going to say my dict is curly brackets. That is an empty dictionary. And if I print it, I'm just going to get the curly brackets out. Now, you'll notice, let me just do something. If I do the same thing I did before, what happens if I print that out? I'm going to get 1, 2, and 3. But that's not really what a dictionary is. A dictionary is an associative list. And so an associative array. So what I want to do here is I want to give my dictionary, or the power of the dictionary is in name-value pairs. So I will start off with the name for whatever the value is. So let's say I'm going to use name, and then I'm going to say my name is Lisa. And then I'm going to say class, and the class is IT 140. Oops. Now there's a very specific syntax going on here. And then I'm going to say, I don't know, student 42. Okay? So there's a very different syntax, and we have what are called name-value pairs. So the name is a description. What is it that the value is? What does the value mean? Well, in this case, Lisa is my name. And in this case, IT 140 is the class number. And in this case, 42 is the number of students, which is not really the number of students I have, but I happen to like the number 42. And so if I print it, we will see name Lisa, class IT 140, students 42. But what you won't see is you won't see an integer. So if I do this, what happens? I get an error. And it just says key error 0. And that's because there are no indexes in dictionaries. There are only key value pairs. If you have the curly brace, the open curly brace and the closed curly brace, you will always get an error if you put in any index because they don't exist. However, if I put in the key, what I will get is I will get the value. So dictionaries are important when you are trying to associate meaning with a value. If you remember the list, we just had the word Lisa. We just had IT 140. There was no description. There was no meaning to that. Because there was no description and no meaning, could have been anything. Dictionaries provide an association between a meaning and a value, and they're very handy. And they will come in very handy in your game because you'll have a room, and you'll have directions, and you'll have items, and all of those things are going to be important. You have dictionary operations, so we just saw myDict with key. And you can change the value. So I can say myDict of name is now going to be equal to Millie. And then if I print it again, same print statement, I will get the name Millie. So it started as Lisa and it's as Millie, and this is what I did. Now you'll notice that the syntax here and the syntax for printing is the square brackets, and that can be sometimes confusing for students because they think, well, I've created a dictionary and it has curly brackets. Why in the world do I have square brackets here? I can't answer the why, but I can tell you that this is how you access information in a dictionary. You always have to use the square brackets around the name of the key. Let's keep going. Methods on a dictionary. You can clear it, you can get a key, you can update a dictionary, and you can pop information. And you'll notice all of these have the key. These have the key in them because whenever you're accessing data inside a dictionary, you have to do it based on the key. So how do I iterate over a dictionary if there are no indexes? Well, there's a key, and you can use for key in dictionary. So if I want to loop over things in my dictionary, I'm just going to comment these out real quick. You can do this. You can do for in my dictionary, in myDict, and I'm going to print and we'll just make that, and we'll just make that a little bit more readable. So if I run this now, I get myDict of name is Lisa, myDict of class is IT 140, and myDict of students is 42. So I am accessing, or I am getting at the data inside my dictionary by using the key. So difference between dictionary and lists. Lists have an index, dictionaries have a key. Okay, so here are some other ways of iterating over a dictionary. You can get the items, you can get the keys, and this is very handy sometimes. Dict.keys will give you a collection of keys. They'll give you a list of keys. And values will give you a list of values. So sometimes you don't care about, you do not care about that key at all, you just want the values. Sometimes you need to know what the keys are. So that is what's important. And this items will give you the key and the dictionary, and it's almost like you're returning, you're having a multiple, you have multiple variables from a return statement. So you can convert dictionaries into lists. I don't think we do much of that. You can nest dictionaries. You can nest one dictionary in another. You can nest lists in dictionaries. You can nest dictionaries in lists. So you can do pretty much whatever you might need to do in them. Now, when we look at this, and I just wanted to look at this really quick, this is something called grades. Okay, it's just a dictionary called grades. That dictionary is a collection of dictionaries. And each dictionary, the key for each of the dictionaries inside the grades dictionary is the name of a student. And then inside the inside dictionary, the inner dictionary, in one case has a list, and that list says of homework grades. So there are a myriad of ways you can combine what the data structures are. Word frequencies. Word frequencies is okay. Program outputs those words and their frequency. Write a program that reads a list of words and then outputs those words and their frequencies. Okay. So it's going to read this list in, and then it's going to output. Now this is, even though it's a dictionary, this is not a dictionary task. And this is going to use one of those data structure functions that we talked about, where you're able to get the number of times an element happens in a list. So even though we've just done dictionaries, this is the 6.18 is list. And you're going to use one of those lists to get the frequency. You're going to use, one of those list methods to get the frequency. Replacement words. Okay. This is write a program that replaces words in a sentence. The input begins with the word replacement pairs, original and replacement. The next line of the input is the sentence where the word is to be replaced. So in this case, you're going to have automobile and car, manufacturer, maker, and children, kids. So this is going to be the original word, and this is going to be the replacement word. And then you're going to go through and you're going to replace it in the string. I think, and that brings us to 7. Sorry I kept you over some. Does anybody have any questions? Okay, go for it. Okay. on the project using a dictionary and a while true loop to code the game for movements. What I'm stuck on right now is accepting inputs in both upper and lower case. So I use south and south with my directions and list dictionary, or is there a better way I could be doing this? Is what I came to expect either lower or uppercase words, but I feel like I'm forgetting and don't know something I should. Well, there's a couple of different ways to handle that. Now, you don't necessarily have to deal with the difference between upper and lower case, but if you're worried about accepting strings in Python that are upper or lower, you can simply convert them to all being lowercase or all being uppercase, and then check them based on that. So if you, let's say, had a dictionary, and let me just do this. Oh, sorry. I was trying to do the lower and upper, but I could get it to work, but I couldn't get it to work with my code. So let me just do a quick example. Oops. Okay, so I'm going to have stop equal go. I'm going to say while so let me just do this. I'm gonna come up with just and now you let me know if this is not what you're talking about. Actually, this is the best way to do that. Sorry. I keep doing the parentheses. Ignore my open and close parentheses tonight. I'm thinking Java. Oops, my bad. So this is just a quick example that I'm hoping is illustrating what you're asking, Noah. Okay. So I'm just going to run this real quick. And so I'm going to enter a direction. I'm going to say south. And it's going to say the direction is valid. And the direction is valid because I am comparing all lowercase north, south, east, west to what's in directions. So that's one simple way to do it. Everything is lowercase here in directions, and I am just turning this to lower. Now what if I wanted my directions camel case? What if I wanted it like this? Because that's the way I want to print it out to people. Well, there's another way to do this, okay? Rather than do in directions, I could do a for loop here. And I could say for index in range directions, oops. And then I could say if val.lower, actually let me do this, found equal false, oh, there it is. So I will say if lower in directions, if val lower equal dot lower, then I'm going to say found is true. And then when I'm all done, and I'll break. And then once I've broken out of here, I'm going to say if found print direction is valid, else print is not valid. So if I run this, I'm going to enter a direction. I'm going to say south. And I'm going to say the direction is valid. I'm going to say north, all uppercase. The direction is valid. I'm going to say west. The direction is valid. I'm going to say www.est. Direction is not valid. And I'm going to say Q. Whoops. My bad. The first thing I need to do is check if stop is Q, break. All done. So now I can actually stop. So if I do this again, I'm going to say north. We've seen that that works. I'm going to say Q. Whoops, if stop, val is Q. See, gets be after 10 o'clock and I have no brain left. I just have none. So I'm going to say north, that works. I'm going to say Q, and I'm done. So is this the kind of thing you are asking about, Noah? Okay. Does this answer your question? Okay. So that's how you would handle it if you are trying to take any combination of letters for west. That is, that spells west, but it's upper or lowercase. And you also have to make sure that you break out when you need to break out. Okay, so where to place it? if you're worried about where to place this, I would place it, my suggestion would be that you always check the validity of every input at the time at which you get the input. So in this case, I am taking an input for direction. So I want to, well, I'm entering a direction or cue to quit. So here, the first thing I'm doing is I'm going to check to see whether they want to quit. Because if they want to quit, we're done. Then go check the validity right away. Because you don't want to go do things when you don't need to do them. So if that answers your question, we're all good. Does anybody else have any questions? Okay. If nobody has any questions, I'm going to call it a night. Thanks for sticking around, and this will hopefully be posted tomorrow. And I'm going to stop.